Okay, what I'd like to look at now is rational expressions. It will be the topic of these next couple of videos. And I want to look at specifically reducing rational expressions. And this is very similar to the notion of reducing fractions in the real numbers. For example, if we looked at the fraction 9/12, well, this fraction can be reduced. How would we do it? Well, many of you can just reduce this in your head, and you don't really think about the process. But one way of thinking about this is I'm going to write the number 9 in terms of its factor, a couple of its factors, and I choose to write it as the factor 3 times the factor 3, all over the factor 3 times the factor 4. Notice we've written this in terms of factors, and we see that the numerator and the denominator share a common factor, and we reduce those two factors out, and this simplifies then down to 3/4. So this is what you're used to doing with the real number system, and we're going to do the same thing with rational expressions. Okay. So let's look at the following example. Oh boy. So the directions here are to reduce, which is the same thing as simplify in this case. This thing doesn't like to do the tops of i's. Okay, let's reduce or simplify the rational expression 2x cubed minus 16, all divided by x to the third power plus 2x squared plus 4x. Okay. So just like with fractions, we want to reduce this down. That means we're going to have to reduce out any common factors. Well, at this point, both the numerator and the denominator are written in expanded form, and we can't identify their factors. So the first thing we better do, if we're going to reduce this, is factor it. In the numerator, I can factor out a 2. Okay. This leaves me with x cubed minus 16. Or excuse me, that's incorrect. X cubed minus 8. All divided by, and in the denominator, I notice that I can pull out a like factor of x from each of the terms. So doing so leaves me with x squared plus 2x plus 4. Okay. I don't know if you were able to notice it in the beginning, but now, once we've pulled out that factor of 2, we see that in the numerator we have what's called a difference of perfect cubes. X is being cubed, and a number here is being cubed, the number 2. So we can factor this difference of perfect cubes. If you've forgotten how to factor sums and differences of perfect cubes, there's a video on that under the basic skills. So let's go ahead and factor that numerator. This is 2 times x minus 2 times x squared plus 2x plus 4. And the denominator, we should check to see if we can factor it further. Okay, we have a trinomial here, but it does not factor down any further in the real numbers. Which is okay. Now looking at this, we have written these, both the numerator and the denominator, as products of factors that cannot be reduced any further, and we see that both the numerator and the denominator share this common factor, the trinomial factor, and we can go ahead and reduce those out. Thank you. Yes, you're very helpful. And then that's equal to, just cleaning up our mess here, that's equal to 2 times x minus 2 all over x. And we've reduced the original rational expression down as far as we can by canceling out all shared factors.